The fastest way to waste money on soft plastics is to buy 5 bags that look different on the shelf, but become nearly identical underwater. A tackle store wall can make 50 colors look like 50 different tools. They aren't. Most collapse into just 3 base jobs and 1 useful modifier. And here's the part most color charts miss. 2 baits, both labeled green pumpkin, can look more different underwater than green pumpkin and watermelon. That's because fish don't see the name on the bag. They see how much light passes through the plastic, how strongly it separates from the background, and what changes as the bait moves. Once you understand those differences, you can build a useful color selection with a handful of genuinely different baits. You'll also understand why plain black can sometimes remain easier to locate in muddy water than the brightest fluorescent color on the shelf. Start by holding 2 soft plastics up to a light. Don't compare the names. Compare what the light does. A thin finesse worm may glow around the edges and allow the background to show through it. A thick creature bait in the exact same named color may appear dense and nearly solid. Add different amounts of pigment, salt, flake, or differently colored layers, and the 2 baits can create completely different underwater signals. That's the first buying trap. Color names describe recipes, not guaranteed underwater results. Green pumpkin is a useful example. One version may look like a soft, translucent green-brown. Another may create a dark olive silhouette. A third may contain so much colored flake that it flashes every time the bait bends. They share a name, but they don't necessarily perform the same job. So instead of collecting color names, organize your soft plastics by 3 base jobs. The first is subtle imitation. These are the muted or translucent colors that look plausible without creating an especially bold target. Green pumpkin, watermelon, smoke, translucent brown, and lightly pigmented natural colors often fit here. The second is pale visibility. Pearl, bone, solid white, and opaque baitfish colors create a lighter, more obvious target. They can still imitate prey, but they're easier to separate from many dark underwater backgrounds. The third is dark silhouette. Solid black, black and blue, Junebug, and dark purple may look different in your hand, but their main advantage is similar. They preserve a dark outline when fine color detail becomes difficult to see. Then there's the modifier, a deliberate accent. That might be a chartreuse tail, an orange belly, colored flake, or 1 contrasting layer. An accent doesn't always create a completely new base color. It changes where and how the bait attracts attention. Those categories are more useful than memorizing that one named color is always best in one type of water. The right job depends on what the plastic becomes after it enters the actual scene. Clear water is the easiest place to see why. When more light reaches the lure and fish can potentially inspect it from farther away, a subtle imitation is a sensible starting point. A translucent green pumpkin finesse worm can produce a softer outline than a thick, opaque version. Smoke can make a minnow-shaped bait look restrained. Watermelon may appear lighter and greener than green pumpkin, especially in thin plastic. But natural doesn't mean invisible, and it doesn't mean matching the bottom perfectly. Put green pumpkin over pale sand, and it may become an obvious dark object. Move it over vegetation, or a dark bottom, and it may blend much more closely. The same bait hasn't changed. The background behind it has. That gives you a better question than, what color works in clear water? Ask whether you want the bait to blend enough to look plausible or separate enough to remain easy to track. If fish are approaching a bait but repeatedly refusing it, a softer version of the same general appearance can be worth testing. You might compare an opaque natural color with a more translucent one, or heavy flake with little or no flake. That doesn't prove color caused the refusal. Size, action, retrieve, rigging, and fishing pressure can all affect how fish respond. The point is to make one controlled visual change instead of abandoning the entire color family after one reaction. And that same principle becomes even more important with baitfish colors. Smoke, translucent gray, pearl, and solid white can all suggest small fish, but they don't create the same target. Smoke is the subtle option. It allows more background through the body and can work when you want a soft outline. Pearl creates more reflection and a brighter body. It can imitate the pale flash of a baitfish turning through the water. Solid white is usually more opaque. It creates a clean target, and it can also help you see the lure well enough to notice when it vanishes during a strike. So don't ask whether white or smoke is universally better. Ask how obvious the baitfish imitation needs to be. If fish are actively chasing prey, Pearl or white may give them a distinct target within the commotion. If they're inspecting without committing in bright, clear water, smoke or another translucent baitfish color can be a useful comparison. But the base color is only half of what a soft plastic baitfish pattern does. Movement can completely change the pattern. A paddle tail that tracks upright may display a dark back and pale belly consistently. A soft jerkbait that rolls during a twitch may alternate those layers, producing a repeating dark light flash. If a swim bait runs on its side, the carefully designed back and belly pattern isn't doing what the package suggested. Move the bait beside the bank or boat before deciding what its laminate actually contributes. Watch it at the speed you'll fish it. The color that appears during the retrieve matters more than the pattern sitting still in your hand. Now, let the water lose some clarity. Suspended particles scatter light and reduce how far subtle edges and small color differences remain useful. A translucent watermelon bait that looked alive in clear water may become difficult to separate from its surroundings. This is where many anglers begin buying increasingly brighter colors. Sometimes that works, but brightness and visibility aren't the same thing. A pale, opaque bait may remain easy to locate against dark vegetation. A darker bait may produce a cleaner outline against light coming from above. A fluorescent accent may remain noticeable when a muted base color disappears. The useful adjustment is the one that increases separation from the background the fish is viewing, not necessarily the one that looks loudest under store lighting. Lightly stained water is where your categories begin to overlap. A natural green pumpkin may still be perfectly readable in bright conditions. If it fades into the background, you could test a more opaque version without changing to a completely different hue. You could compare it with Junebug or black and blue to create a darker outline. Or you could keep the natural body and add one chartreuse or orange accent. Those are three distinct experiments: more opacity, a darker silhouette, or a localized point of contrast. Changing from red flake to purple flake may look like an experiment, but if both baits remain visually identical underwater, you haven't tested a meaningful difference. You've just opened another bag. And that brings us to the muddy water exception. It seems logical that the brightest fluorescent bait should always be easiest to find as the water gets dirtier. But fluorescent material still needs suitable light before it can appear bright. A yellow-green bait can also lose separation in water with a similar green, yellow, or brown cast. Black doesn't need to appear colorful. Its advantage is the boundary it can create between the bait and whatever light remains behind it. In muddy water, deep shade, or low light, that dark shape can sometimes remain more coherent than a pale or fluorescent bait. You can test this without pretending your eyes work exactly like a fish's. Place a black soft plastic and a fluorescent one in the water you're fishing. Look at them against open water, the bottom, and nearby cover. Turn them so the background changes. Lower them only as far as you can do safely and still retrieve them. You're not proving which color every fish will see best. Fish vision differs by species, viewing angle, distance, and conditions. You're identifying whether one bait quickly loses contrast while another retains a useful outline. That comparison also explains why one color can perform differently during the same retrieve. A fish looking upward may see the bait against light from the surface. A fish looking downward may see it against sand, vegetation, rock, or dark bottom. Pearl can separate strongly from weeds. Green pumpkin can look more restrained within them. Black can create a sharp silhouette against surface light, but lose some separation against dark muck. Color isn't a permanent property of the lure. What matters is the relationship between the plastic, the available light, the water, and the background behind it. Once your base color performs the right job, accents become much easier to understand. A chartreuse tail can create a small aiming point without turning the entire bait fluorescent. An orange underside may echo a noticeable feature of local crawfish. Silver or holographic flake can send brief reflections as a paddle tail bends or a jerkbait rolls. But flake is usually a modifier, not a completely new tool. Green pumpkin with red flake is still primarily a green pumpkin natural color. Smoke with silver flake is still primarily a subtle baitfish color. If the flake is too small, too sparse, or rarely exposed by the bait's movement, changing its color may make a bigger difference to you than it does underwater. That doesn't make flake useless. It means you should buy it for a reason. Use reflective flake when intermittent flash supports the prey you're imitating. Use a contrasting tail when you want one part of the bait to remain especially noticeable. Use an orange accent when it supports the appearance you're trying to create. If you can't describe what the accent changes, It probably doesn't deserve a separate place in your starter selection. Red deserves the same practical treatment. Red wavelengths are generally reduced relatively quickly as light travels through water, but a red soft plastic doesn't become invisible at one universal depth. Its appearance depends on clarity, sunlight, viewing distance, the plastic itself, and the other light it reflects. It may look muted, brownish, or simply darker. Choose red because it creates a useful accent, resembles something in the local forage, or changes the bait's outline, not because of a rigid claim that red always disappears at a particular depth. Ultraviolet reactive, fluorescent, and glow plastics also have real optical properties, but none replaces the basic jobs. Fluorescent plastic needs suitable wavelengths of light. Glow material must absorb energy before releasing visible light. Ultraviolet visibility varies with material, depth, water, light, and the visual abilities of the species you're targeting. These options can be useful when you can give them a specific purpose. They aren't automatic upgrades over a convincing natural color, a pale visible target, or a strong dark silhouette. Now you can reduce the entire tackle store wall to a practical starter selection. For each soft plastic style you regularly fish, carry one subtle natural option. Green pumpkin is a versatile place to begin, but watermelon, smoke, brown, or another locally useful natural color can fill that role. Carry one pale, visible option. Pearl or solid white gives you a meaningfully different baitfish style target. Carry one dark silhouette option. Black, black and blue, Junebug, or dark purple can fill this role. You don't need all of them before you've established that their underwater appearance is genuinely different. Then carry one deliberate modifier. That might be chartreuse dye, an orange accent, reflective flake, or a laminated pattern whose movement you've actually checked. That isn't a list of magic colors. It's a set of different experiments: subtle imitation, pale visibility, dark silhouette, and controlled accent. When you compare them, keep the test honest. Use the same bait model, size, rig, weight, and retrieve when possible. Compare colors that perform visibly different jobs. Fish them through several reasonably similar opportunities rather than giving one color the best cast and the other a single throw into empty water. Don't treat one fish as final proof. One bite can happen for reasons your test didn't control. Look for repeated differences in follows, approaches, strikes, or catches. And interpret those reactions carefully. A follow tells you the bait was noticed, but it doesn't prove color caused the refusal. A missed strike doesn't automatically mean the fish needed a brighter tail. Those reactions give you a reason to test a controlled visual change, not permission to ignore every other variable. If you receive no observable reactions at all, you haven't learned that both colors are bad. You've learned that the comparison produced no useful color evidence. Adding 6 more nearly identical shades won't make that evidence clearer. So the next time a wall of soft plastics gives you 50 choices, don't begin with the names. Hold the bait to the light. Notice whether it's translucent or opaque. Check what its layers and flake do while it moves. Think about the background it must cross. Then assign it one base job: subtle imitation, pale visibility, or dark silhouette. Add an accent only when that accent changes something you can explain. And when muddy water makes the brightest package look like the obvious answer, perform the comparison most anglers skip. Put the bright bait beside the black one in the actual water. The best color isn't automatically the most realistic, the brightest, or the one with the most convincing name. It's the soft plastic whose useful signal survives the trip from your hand to the fish.